Hey guys, today we're going to learn about the area of trapezoids. So let's go ahead and get started. Okay, that first blank, it says blank, the amount of space inside a two-dimensional figure. Well, we've been filling that in pretty much this whole time, and it's the word area. Area is the space inside. So think about the inside, not the outside. The inside, that's the area. Now go ahead and let's take a look at these next two shapes here. I know there's a question up above, but it's important to look at the picture in order to be able to understand or answer the question. And I know I have the question or the answer filled out, but just pause for a moment and look with me. So if I look at these two shapes here, I see that I have a parallelogram, and then I also have another parallelogram. But then I notice with my second parallelogram, it's cut diagonally. And if I take a closer look, I see that I have a trapezoid and then another trapezoid. So one's facing up and the other's basically facing upside down. So the question is, what is the relationship between a trapezoid and a parallelogram? Well, essentially, they're both parallelograms, right? But one parallelogram can make two trapezoids. Now, if I'm going too fast, remember you can always pause the video. So I'm going to keep scrolling here. It says formula for area of a trapezoid. Now this is where you need to take a look at your formula chart. I'm going to go ahead and write it down. It is A equals 1/2, and then in parentheses we're going to put B1 plus B2 and then H. Now if you remember from earlier last week, B stands for base. In this case, a trapezoid has two bases. So B1 stands for base 1, and then B2 stands for base 2. And then H, as we all know, means height. Again, if I'm going too fast, feel free to pause this video. The formula for area of a trapezoid is 1/2 because a trapezoid is half a parallelogram. And that's true based off of what we just saw in the picture up above. Okay, then this next one says the bases are B1 and B2 because, and y'all learned this last year, but in case you forgot, they are parallel. That's why. So they're parallel, they're across from each other. Remember, parallel means that there are two lines that go on forever and they will never intersect. So let's take a look at number 1. We have this trapezoid. We're going to identify our two bases. So I'm just going to go ahead and highlight them. So I have this one and I have this one. And then we have our height. And remember, our height needs to be perpendicular at a 90-degree angle. So generally speaking, it's going to be this dotted line right here. I'm going to go ahead and label everything. I'm just going to say the top base is base 1, and then the bottom base is base 2. And then 9 will be our height. So first things first, I'm going to write my area formula. So I have A equals 1/2, parentheses B1 plus B2 times the height. And now I'm just going to go ahead and substitute in what I know. So I have A equals 1/2. Instead of B1, I'm going to put 8 plus, instead of B2, I'm going to put 12, and then close those parentheses. The height is 9. So I'm going to solve this just like I would PEMDAS. So PEMDAS, the first thing is parentheses. So I'm going to solve what's in parentheses. So I'm going to write the rest of my formula. I have A equals 1/2. 8 plus 12 gives me 20. And then close those parentheses, 9. Now this is a lot like solving a triangle. And remember, we're going to half. If we have an even number, we're obviously going to do that. So I'm going to half 20, which gives me 10. A equals, in parentheses, 10, and then 9. Remember, if there is no sign between those two numbers, that means to multiply. So I'm going to write A equals 90. And I'm going to go back and look at my units. And it's centimeters, and remember, area is squared because we're technically multiplying by 2 dimensions. We're doing base times height. And yes, there are two bases, but we add them first before we multiply by that second dimension, which is the height. All right, let's take a look at number 2. Same idea. Let's identify those bases first. So we have 2 and we have 8. And then the height is that dotted line. Remember that 90-degree angle. What is perpendicular? We're going to write our area formula down first. We have A equals 1/2. In parentheses, we have base 1 plus base 2 times the height. So let's go ahead and label. I'm just going to say the top base is base 1 and the bottom one is base 2. It doesn't matter because if you add the two numbers in whichever order, you're still going to get the same answer. That's just what I do for like me to keep it consistent. And then 11 is going to be the height. Now we're going to substitute in what we know. So we have A equals 1/2. Instead of B1, I'm going to put 2 plus, instead of B2, I'm going to put 8. And then the height is 11. All right, I'm going to do PEMDAS. So I have to add what's in parentheses first. So I have A equals 1/2. 2 plus 8 gives me 10. And then close those parentheses and put 11. I'm going to half my even number because that's just the easiest thing to do here. So half of 10 is 5. Another way to look at it is 10 divided by 2. And then close those parentheses and put 11. So there is no sign between. So what that means is I'm going to multiply. And I'm going to write A equals 55. Go back and look at my units. Feet squared. Okay. Let's go ahead and take a look at the next one. We're not going to solve it, but it is sideways. So remember, you can always turn your paper if you want to, so that way you can see what's parallel and what's not. Now looking at this, if I say 5 and this one are the bases, well, eventually if I extend this line, it's going to intersect with that line. So that's not parallel. Remember, parallel means two lines that will never intersect. So it's going to be 7 and 19. And then the height in this case is going to be 5. Now there is no right angle, but if you take a look, it would make a perfect right angle. So then I would just label base 1, base 2, and then height. And then I would just plug it into my formula and solve. And then let's go ahead and take a look at this last trapezoid. Now, same thing here. It kind of looks like a rectangle, but you can see that these two lines right here actually do, they don't make a perfect 90-degree angle with the corners. And so eventually those two lines would intersect. So those are not going to be our bases. Our bases are going to be 15 and 17. And I know this because I do see that right angle this time around where that 4.5 intersects at. So that tells me right there that the two bases, that those are what's parallel. And the 4.5 is what is the height. And then again, I would just label. So I'm just going to say 15 is my base 1, 17 is my base 2, and then 4.5 would be my height. And then I would plug it in and solve. All right. Good job finding area of trapezoids.